All right, this is going to be some implicit. These next couple videos are going to be all about implicit. All right, so I got x squared plus y squared is equal to 8. Remember, when you want to use implicit differentiation, that is when you have variables. Well, you have your y variable, and that there's operations with that y variable. So it could be multiplication, it could be exponents, anything like that. If y is already solved for, then you can just take derivatives like you normally would. All right, but the y has a variable or has an exponent on it, so we're going to have to use our implicit. All right, so we're going to take the derivative of x squared like we normally would. It's 2x. All right, now when we take the derivative of y squared, there's actually two functions. You have a linear function, which is the y variable, and then you have a quadratic function, which is squared. So we're going to use our chain rule, basically. So we'll take the derivative of our quadratic first. We'll drop the exponent, subtract it by 1, and then you have to take the derivative of the y variable, which is going to get you y prime. So when we take the derivative of y squared, that's going to be chain rule. So it becomes plus 2y times your y prime. And don't forget the derivative of 8 is 0. All right. Now all I'm going to start to do is solve for y prime. I want to have it so it says, hey, this is the derivative, this is what it equals. When I use derivatives, it's all about slopes. All right, so we're going to go ahead and write that as 2y prime is equal to a negative 2x. I just subtracted the 2x over. I'm going to divide both sides by 2y. So I get negative 2x over 2y. And then I simplify, and I get negative x over y. That is implicit differentiation.